All right, so today we're going to continue looking at systems, okay, section 12.2. Okay, so yesterday we solved systems by graphing. Okay, why is that not, you think, the best approach? What makes graphing difficult? Yeah? That's a big one. You can't get the exact answer if they don't cross at a nice spot. There's no way you're going to estimate, even 3.75, that problem we did, you're not going to estimate that by hand. It's too hard. Why else is graphing, you think, a bad idea? Or not maybe the best idea? Okay, it's not always accurate. You have to be very careful how you draw it. It's time consuming. Okay? So these are all reasons why we might not want to use graphing. You need graph paper. Okay, you also need a ruler. Okay, you have to draw things perfectly straight. Okay, hard to determine where things cross if it's a decimal. We said that. Okay, we got anything else here? Nope. Okay, so these are all reasons why we need an approach that's better than graphing. Okay, I think graphing is great if you combine it with the calculator, because you can graph two things and then the calculator can tell you exactly where they cross. But unless you're going to use a calculator with graphing, I don't think graphing is the best way to do it. All right, so we're going to look at a new method for solving systems. Okay, and that method is called substitution. Okay, it's the first of two methods that we're going to learn that just use algebra. Okay, you're not going to draw graphs, you're not going to need graph paper, nothing like that.
So guys, you got that first sentence on your notes. It says, today we will solve systems using what?
Using substitution.
We'll do substitution today. What did we do yesterday? Solve them by doing what? How did we solve them yesterday? What do we have to do? Yeah, we graphed yesterday. All right, so we said, we're only going to get into two, I mean, like Mr. Hager said yesterday, there's a bunch of different methods. We did graphing yesterday. We're going to do substitution today and again tomorrow, right? And then the third method we're going to talk about next academic. All right?
Okay, it says linear. I don't know if I've emphasized this a lot, but what does linear mean? Because solving linear systems is very different than solving non-linear systems, which we're not doing. Did anybody see a word in linear? Like part of that? Yeah? Straight line, yeah. Line, okay? So we're basically finding where lines cross. Okay? When you take other classes, maybe Algebra 2, or if you take any trig, we can do not just where lines cross, but we could figure out something like this. Okay, this is where a curved shape and a line cross. Okay? We're not solving systems like this. Okay, every system we solve, it's just where lines cross. Okay, that gets a little more complicated. Right, so the big idea with substitution is you're plugging things in. Okay, you're going to be replacing a letter with something. Okay, and as we go through, we'll show you. Okay, so you're replacing a letter with an expression.
Yeah, so guys, that first blank is going to be substitution. Then it says which is. You're going to write I'm plugging an expression for a particular value.
Okay, what's nice about substitution is you always get the exact answer. Whether you have a decimal to work with or problems that are just nice numbers, with substitution it doesn't matter. Okay, we can use a calculator and we will always get the exact answer. So that's a big advantage over graphing.
Guys, how many, and I know there's quite a few people, how many people play sports or have played sports? All right, so the word substitution kind of comes into play when you play sports, right? How come? Why?
Why?
Yeah, how come?
Because it's changing something.
Yeah, you change, that's what we're gonna do today. We're gonna change something. So we're gonna have like on your notes, you see it, there's like these little catchphrases. It says like, get the sub ready. Like for you guys, what do you do in hockey? What do you guys say?
We usually just bang the boards and then people, like, we yell out our position and then they'll know.
Or sometimes they say like, change it up, right? Oh, Victor, sometimes in basketball, right? The coach will be coaching the game, all of a sudden he'll turn around and say, you know, Victor, get ready to go in, right? So you gotta kind of say, okay, you're going in to play the, you're going in to play the 5, you're going to play 7, right? So you gotta make sure that you're ready to play that position. Same thing here. We're taking something out to put something. We're gonna plug in something in. Like you come on, like basketball, you come off the bench, raise your hand, hey, I'm in for you. You guys switch, right? So we're gonna try to kind of put this in for some of you guys. Because it can be a little bit hard to understand. I think maybe we put in like terms you guys understand. It might make it a little bit easier. All right. So this is how we're gonna solve them. So first thing you're gonna do is get like, what's up, Brian? Yep. How far, buddy?
To that, right there.
Yep. Okay, I can leave that up there. That's fine. All right. We can leave both up there, Mr. Hager, I think. Yep. All right. So what you're gonna do is you're gonna get your sub ready. So kind of like, let's think about like slope intercept form, like y equals mx plus b. What do we have to do to make sure that equation is ready to graph? What do we have to do? Anybody remember? What are we gonna do to make sure? Maria? Make sure y is by itself. That's what we're trying to do. That's what Mr. Hager and I mean by getting the sub ready. You've got to make sure because remember, systems are going to have 2 variables, usually x and y. Right? So you've got to make sure one of those guys, just like we do with slope intercept, is by itself. Right? We've got to make sure that we have that. So in one of your equations, you're going to look for and or get a letter by itself on one side of the equal sign. Some of them we do in this part of the notes might already be by themselves. Right? They might already be set up. They might already be done for you. But it's kind of like you're sitting there on the bench, coach turns around, get ready to go in. Maybe you're gonna tie your sneakers a little bit tighter, football, make sure your helmet's all set, all tightened up, ready to go. Right? That's what we're doing here. We're getting whatever we're gonna substitute in, we're getting it ready to go. We're getting ready to go into the game.
Mr. Roy, do we have to get y by itself all the time, or we?
No, either one. And we're going to talk about this because sometimes if it's not like if x or y is not by itself, it might not have a number attached. It could be like x plus y equals 2. All I would do is move the x. I just minus x. Then I'd have y equals 2 minus x. Y is by itself, it's all set to go. Or you could have done it the other way too. You could have subtracted y, did 2 minus y, and you still have a variable by itself. So it doesn't matter which one you use. It could be because most of the ones we're going to do and the ones we do on the test are going to be x and y. The ones we give you on the homework are going to be x and y.
So that's a little different. We always had to get y by itself before. With substitution, you can get x by itself if you want. So that's a little different. We do whichever one's easier.
All right. So like I said, the first step, we're going to make sure that one of those variables or what we're going to substitute in is all set, all ready to go into the game. All right. So if I look at, you guys don't have this example on there, but I want you to write it in. And like I said, sometimes that step might already be done for you. All right? You may already have a variable by itself. Or you might have a variable that's by itself with no number. It might not be in that order where a variable's by itself, but you might have that variable with no number attached, and then you can move everything else. So you're always trying to look for that single variable. So you're always trying to do. Make sure you get it ready. So in this this example, do I have a substitute that's all ready to go into the game? Do I have a variable that's by itself on one side of the equal sign? Do I have that in either of those equations? You say yes, Caitlin. Which one? The first one, right? Y is by itself. All right. There's nothing else over here. This guy is all set to go. All right. He doesn't have to do anything to get ready to go into the game. He's all set. He's ready. All right. This guy is all set, ready to go. He's by itself. He's all ready to go. So now we go step 2. We're gonna get that stuff. We're gonna get it into the game. All right. We're gonna plug it into the other equation. All right. So we're gonna substitute, or like we call it a lot of times, guys, plug it in. We're gonna plug in the information, like Mr. Hager just put a box around, the information after the equal sign into the other equation and solve. All right? And that, remember, when we do systems, we always get 2 answers because we're solving for x and we're solving for y. All right? So all the information that comes after the equal sign, so y is by itself, this information is going into the game for y. All right? That negative 3x plus 5 is going into the game for y. I'll let you guys get caught up before I show you what's going to happen. And Mr. Hager kind of already showed you guys kind of how to think about what's going to happen. So that negative 3x plus 5 is what is going into the game, right? We're going to say like this equation right here, this one down here, that's the game, right? This is the big game. This is the big game down here, all right? So this negative 3x plus 5 is ready to come into the game, all right? So I'm using everything I do now, everything I do for this part is based on this equation. This is the game, all right? So I'm going to start with negative 6x, because this is the game. This is the equation that I'm using. This is the equation I'm going to substitute into. Plus y, but y is coming out of the game. I'm substituting for y. Who's coming into the game for y?
Negative 3x plus 5.
Negative 3x plus 5. That's what's coming in. Negative 3x plus 5. That's what I'm substituting in. What's left? Equals, because that's what's left in the game down here. That's what's left, is equals negative 1. All right? So like I said, I'm taking this information, because it's by itself, and plugging it in. All right? It's coming into the game for y. Y's out right now. We'll come back to him after. Because he's going on the bench right now to get some rest. He's going to come back in a second. All right, but he's taking a little break right now. All right, so now, this is like an equation we've solved 100 times before. All right, what's the first thing I'm going to do? Who can tell me? What's the first thing? Alex, what do you think? Combine like terms, right? That's the first thing I'm going to do is combine my like terms. What are my like terms?
Negative 6x and negative 3x.
What do I get? Huh?
Would it be 9?
Negative 9, good. All right, good. X plus 5 equals negative 1. All right? Now, what's the next thing I'm going to do? What am I going to do next? Gage?
Minus 5.
Minus 5, okay. What else am I going to minus 5?
Negative 1.
Negative 1.
It's going to be negative
4. All right. On the other side, what do I have left?
negative 9.
Negative 9x. All right? Victor, last step.
Divide 9.
Divide by what?
9, -9.
Good man. So I'm going to get x equals, Victor, is my answer going to be positive or negative?
Positive.
Positive, right? How come?
Negative.
Right. Am I going to put my answer as 6 over 9?
No.
No. What am I going to put? Logan?
3 over 2,
3 over 2. What number did you reduce by?
just, well.
Careful with your answer.
Yeah, careful with your answer too. I'm going to reduce by 3. I'm going to divide by 3, right, to reduce it? Because 3 goes into both things. So 6.
Did I say 3 over 2?
Yeah.
I meant 2 over 2.
I know. Sorry. All right. So x equals 2 over 3. But remember, I'm solving for a system of equations. How many answers do I have to have? 2, right? I solve for x. What else do I have to solve for? I have to solve for y still. So this is when, like I said, y went to the bench. Y is on the bench right now. This is when he's going to come back in. Right? He's going to come back into the game. So we got this guy. So now we got to get another sub. We got a sub again. All right? We got a sub. We're going to use this x now. The x we just solved for, and plug into an equation to get my y. All right? So now, sorry, mistake. So now, this is different from before because when we substituted for y, we had a variable and we had a number, a constant. But when we solved here, all we have is one number. So all we're doing is plugging in for one thing. We don't have two things. Rose.
I'm confused because I was trying to catch up. How did you get negative 6 divided by 3 from negative 1 minus 5?
Negative 1 and a negative 5 gives me negative 6.
Where did the divide 3 come from?
I reduce this.
Reduced it.
Yeah, I reduce by 3 because 3 goes into both things.
Oh, okay.
That's all. You back with me?
Yeah,
Okay, good.
sorry.
It's all good. I want to make sure you're with me. All right? So now, like I said, we're going to have that one number that we're going to substitute for. All right? And then we'll use multiplication. That'll give us our second answer, and we're all done. All right? Now, I want to solve for, what equation do I want to solve for now? X or Y? I mean, what variable? I'm sorry. What variable do you want to solve for now? Y. Which, I like where you're going, Corey. Corey says, let's use this top equation to solve for. All right, let's plug X into that one. How come, Corey?
Because we're solving for the
Yeah. Y is already by itself. Once I do the math here, that's going to give me what Y is. Right? I'm not going to have to divide or anything like that. I'll multiply, I'll add or subtract, and I'm done. I don't have to minus one thing on one side, minus one thing on the other. If I do my multiplication, my addition and subtraction, I'm done. All right? So extend this a little bit. So, look at that top equation and look at what I solved for. All right? So I'm going to start with y equals. Alexis, do you have any idea what the rest of that equation might look like?
Negative 3
Like it? Negative 3, yeah.
times 2 over 3.
Nice job. You just, there it is. There's the other substitution. I got the x. I'm plugging him. I'm substituting him now. 2/3, and then what's left, Alexis? Plus 5. So guys, I took that x that I just solved for in step 2, the x that came into the game for y. All right. I solved for that, and now I'm plugging that back in, and that will give me y. All right. Mr. Hager, are you going to do that? Oh. So I got y equals, how do I do negative 3 times 2/3? Mr. Hager's going to do it on a calculator.
Yeah, you can just use your calculator.
Yep.
was gonna say, you make it a fraction.
-2.
But you're right, yeah, it's a
Or
negative.
if you wanted to, you could do it just like this, guys. Like Gage just said, -3 over 1 times 2 over 3. We'll get -6 over 3. And then -6 divided by 3 is -2. You can do it that way too. Or if you have a calculator, you know how to do it, you can do it that way as well. All right? Plus 5. When I have -2 and a +5, what do I get? 3. Positive or negative? Positive. So, here's my two answers. X equals 2/3, Y equals 3. All right? And we can write it like this. 2/3, comma, 3. Or if you have or if you write it X equals 2/3, Y equals 3, that's fine too. All right? Like I said, guys, it can get a little confusing. And I think some of you guys out there right now are probably like, oh my God, this is like crazy. All right? It takes a little to, obviously we're not going to do this one example and that's it. We're going to do a couple more. All right? And a lot of the stuff we do, guys, we may give you one or two where you actually have to get one of the variables by itself. Most of the time, it's going to be done for you. It's just a matter of plugging it in. All right? I'm not going to go too crazy with this stuff. All right?
So this one, very similar to what you guys just did. Do you guys already have it written down? Okay. Okay, so as we go through it, look back at the last problem you just did and kind of follow along, and we're going to do the same steps here. Okay. Anyone think they can tell me my first step? What's the first thing I should check for, even if it's already done for me in this problem? I still need to check and make sure that this is done.
If the Y is by itself.
Yeah, if one of the letters is by itself. All right? Is one of the letters by itself, Kevin? Yes. Which equation has a letter by itself? Top or bottom?
Top.
Top, and which letter is by itself?
Y.
So top equation, Y by itself. So now we're ready to go to the next step. Okay. What's my next step? What do I do with that? This is the first of two things we're going to do. What's going to happen with that 2x plus 1? Brian? Not yet. We're going to get x by itself in the next step. But you're on the right track. But we have to do something first before we can get x by itself.
You switch it to Y.
Yeah, we're going to substitute it in. Yeah, we're going to switch. It's going to go in for the y. Okay. So now we're going to rewrite that bottom equation, filling in for y. Okay. Who can tell me what am I going to fill in for the y? I'm not going to write y. I'm going to fill in what? I'm going to fill in 2x plus 1. Okay, so we have 3x plus y. Okay, but we substituted in equals -4. Okay. How many different letters are in that equation now?
Just two.
Different letters?
Oh, no, there's the other.
There's only one letter there. Okay? That's the whole reason of substitution. We had an equation that had 2 letters in it. Now we have an equation with just 1 letter. That makes it easier to solve. All right, Alex, what do you think I do at my next step here?
Combine.
Good, combine like terms. And what do you get if you combine your x's here?
5x
5x. Anything else on the left?
plus 1.
Plus 1. Okay, so far so good. Now I just have 2 steps left, and then I'll be done with one of my letters. Yep.
You minus 1 from -4.
Yep. And on the other side as well. And what does that give me?
-4.
Good, -5. And what's my last step? Get x by itself.
You gotta divide 5 by -5, you get positive 1.
Can you just say one more time what I'm going to divide each side by?
Divide 5.
Divide by 5. And x equals -1. Okay, now am I done? No, I have one of the answers I need. This is going to help me to get my second one.
And guys, most times when you do that, when you substitute it in, right? You got the equation all set to go into the game. You plug it in. Those steps are always going to be the same. You're always going to combine like terms. You're always going to add or subtract to get the variable by itself, and then divide. I don't care what kind of problem you're doing. I will substitute. That's pretty much always going to be the same. Those 3 steps: combine like terms, add or subtract to get it by itself, and then divide to get your first answer.
All right, now, what do I do with this -1? Now that I have it, I got to use it somewhere. Where do I use it? Yep. I'm going to plug it into the first equation for which letter? Yeah, we're going to fill it in right there. Okay, and then once I do that, I'm going to do out the arithmetic, and then I'll know why. So Corey, how would I write this top equation, filling in what we just got for x?
Y equals 2 times -1.
Yep. Anything else?
Plus 1.
Plus 1. Why didn't we just do that to begin with? How come in the first step of the problem, why didn't we just fill -1 in for x? We didn't know it, right? Okay, we got to figure it out first, and then we can use it. 2 times -1 is -2. -2 plus 1, -1. Hey, so you can leave your answer just like that. X equals, y equals. Or, if you want to write it as a coordinate, what would be my answer as a coordinate? Yeah. And now, if I were to graph this, what would happen at the point -1, -1? Think about yesterday. Trying to make that connection with what we did yesterday. If I were to graph it at the point -1, -1, these two lines would do what?
Parallels.
That's where they would cross. Okay? This is where they would cross. Okay, any questions on any of the steps we just did here? Right, so what's nice about substitution, there's kind of a nice flow to it. Okay, you got your equations, you plug something in, you do the work, and then you plug that number back in. Okay, it's almost like a circle. Okay. Let's see, do we have a 1? Let's see, we might have a 1C. You guys want to do another one like this? Because I think we have 2 more that are a little different. Okay, one where you have to get the letter by itself. Okay, all right, we'll try one more like this. Okay, my first question: do I have a letter already by itself?
Yes.
Yes. Which
bottom one.
the bottom equation? Which letter?
Y.
Good. Bottom equation. Y is by itself. Okay. Doesn't.
Actually, no, you don't have. You have one on the top of the row.
I don't have a letter by itself on the top because x and y are on the same side.
Yeah.
Gage, you have y by itself, but it's not by itself on one side of the equal sign.
Right? So now I got a letter by itself. What am I going to do with this 7x? Yep, plug it in for y. Okay, so that's going to go right there. So we're going to get 2x minus, okay, and I always put in parentheses what I'm plugging in. Plugging in 7x. Okay, it's a good idea to put it in parentheses because there could be a time where you have to do a distributive property. Okay, that can happen. Okay, in this case, I don't have a distributive property, but let's say I was plugging in that, 7 plus x. Now I'd have a distributive property, okay? But we're not going to do that on this one. All right, so 2x minus 7x. Yep, negative 5x. I think this is almost similar to what we just did on the last one. So we get x equals negative 1. Negative 1. All right. Now, Gabe, what do I do with this negative 1? Well, what is this negative 1? It's equal to what letter? X, right? X equals negative 1. Do you see an equation that already has y by itself? Yeah, which one? But now we know x, right? What's x? X is negative 1. Yeah, x is negative 1. So we're going to fill in negative 1 for x. So who can tell me what's y? Y is negative 7. Remember, this is multiplication. 7 times negative 1. Right, so any questions on that? Does anybody think after doing a few of these that graphing is better than this? Most people think this is better. You think graphing's better, Ryan? Yeah, everyone, depends if you're more visual, I guess. But, all right, so every problem we've done so far already had a variable by itself. Just to be clear about that, it doesn't matter which letter is by itself. When you're graphing, yes, it does matter. Okay, but when you're doing substitution, it doesn't matter. Okay, so as I just said, each of the previous problems, step 1 was already done for you. Now we're going to look at an example where you have to do step 1. Okay? All right.
So we talked about that. We talked about that and or, because now you might have a variable that's already by itself on one side of the equal sign. Great, step 1's done. You got the sub ready to go in. But you could also be looking for a variable that's by itself. It might not be by itself on one side of the equal sign, but it has no number attached. So you might have to move a few things around to get it actually by itself on one side of the equal sign.
Right, so now you have some choices.
Yeah.
Okay, you've got 4 choices. You can say, all right, I'm either going to pick the top equation or I'm going to pick the bottom equation. And then once you make that choice, you could say, I'm going to get x by itself or I'm going to get y by itself. Okay? And there's no wrong way to do it. You could do any of those 4 choices. We try to do the one that's the easiest. Okay? We try to make things easy. All right? So somebody tell me, you pick either equation, the top one or the bottom one. Okay? Which equation do you guys want to work with here? Top or bottom? Either one here is a good choice. Sam? Bottom. Okay, so Sam chose to work with the bottom equation. Okay, that's one choice made. Now we have to decide, in the bottom equation, are we going to try to get the x by itself or get the y by itself? Which letter would be easier to get by itself? Yeah. Okay, if you have a letter that doesn't have a number next to it, or it's just a 1, that's the one to get by itself. All right? So, Jalen, can you tell me how would you get y by itself here?
Subtract 2x.
Yep, we're going to subtract 2x. We're going to subtract 2x just like we did when we were graphing. Get y equals negative 2x minus 2. Okay. Now from here, this problem is just like the last couple.
Now guys, it doesn't, like Mr. Hager put the x first behind the equal sign. Like slope intercept, it had to be like x had to come after the equal sign. If he put -2 minus 2x, he's not wrong. It doesn't have to follow that specific order, right? The x doesn't have to be behind the equal sign. It could be either way. It doesn't matter.
I think just to be consistent, because that's how we had to do it when we graph, I would get used to doing it that way, because on the test you'll have to. But Mr. Roy is right. You could write it a different way this time, and it would be okay. But I'll stick with the way we've been doing it. Okay, so now I got y by itself. Who can tell me what I do with that? Yeah. Where am I going to plug it in?
For Y.
Yeah, we're going to plug it in for y back in the other equation. Okay. And when I plug it in, what did I always say you should put around it? Always put parentheses around it, just in case. Okay, so we've got x, okay, minus 4. Okay, that's the part we're not changing. Okay, and what am I going to fill in for y? What am I going to substitute in, Kevin?
2x,
Yep,
take away 2.
take away 2. All right, so what's going to end up happening here? What property am I going to use in the next step? Something we haven't done today, but we've done it. We've done it a lot, Ryan?
Distribute.
Yeah, we're going to be distributing. Can you tell me what I'm going to distribute? And make sure you remember what goes with that too. The negative and the 4. Yes. Good job. Okay, so this x stays the same. What's negative 4 times negative 2x? Yep. 8x. And then what's negative 4 times negative 2? Right?
Negative 8. No, 8.
Good. Okay. Any questions on that first step? Okay, a little tricky because you have to remember to distribute, but we did it, so now we're good. Now we can combine like terms. What do I get when I combine my x's here? 9x plus 8 equals 17. So we're getting there. Notice this equation is getting smaller and smaller at each step. That's what should happen. Okay, my next step. Ben, what do I do next?
You would subtract 8 from both sides.
Subtract 8. I like it. Subtract 8. And Ben, what's 17 minus 8?
9.
9. And now my last step, I've got 9 times x. To undo multiplication, I'm going to divide. So what do I get for x? 1. Okay, so now we've got one of our answers. And now what do you do with this value for x? Yeah, plug it back in. Okay? So one thing you got to be careful with substitution is if you get x wrong and x is wrong and you use it to find y, what's going to happen to y?
It's gonna be wrong.
Y is wrong. Okay? So you just have to be very careful when you do substitution. Okay, when I plug it back in, notice I'm plugging it back into the equation that already has a letter by itself. Don't plug it back into the original problem. Plug it back into the equation that you got a letter by itself. Okay, that's going to make it just arithmetic. Y equals negative 2 times 1 minus 2. Okay, Alexis, what's negative 2 times 1? Negative 2. Negative 2 take away 2 gives me negative 4. And that's it. That's the hardest type of substitution problems that that you really can have.
It's a long substitution.
Yeah, there's a lot of steps to it. Yeah.
Is that how it's gonna be on the test?
Yeah, there'll be one, I think one or two of these type.
Like,
Yep.
Okay.
The whole test though, it's probably only going to be like 11 or 12 questions. So it'll be shorter than usual. Usually we do about 17 questions or so, 18.
You guys, in the homework, we gave you two, so you have to rearrange. So I'm hoping that one of them will get done in class, so you only really have one on homework. You'll have to do to rearrange it.
All right, so let's try one more together, and then we're going to give you guys some time to try some on your own. Okay. All right, so last example we're going to do together. Now, this time, when I look at this system, I'm already thinking there's a certain equation I should work with. Okay, last time you really could have done it either way, top or bottom. This time, though, I would pick a certain one. Do you think I should pick the top equation or the bottom equation? Brian? The bottom? Well, the only thing with the bottom is there's a number with x and there's a negative with y. So yeah, I would pick the top. Okay, which letter is pretty easy to get by itself in the top? You could do either one, but there's one that's easier. The x or the y. Yeah, I would get the x by itself in the top. So in fact, you know what? I'll just write that's what we're going to do. So we will get x by itself in top. If you don't want to do it that way, you don't have to, but it is the easiest way to do it. All right, so we got x plus 2y equals 3. What's my one step to get x by itself? And that's why we chose x, because it's only one step. Kevin?
Add x. No, subtract x.
Well, if we subtract x, that would just move it like that to the other side. So x would then be with the 3. It still wouldn't be by itself.
We have to do something with the 2, right?
Yep, the 2 and the y. Yep.
So just minus 2y to 3.
Yeah.
Did we do that in the last one?
We did. We got y by itself in the last problem, but now we're getting x by itself. So I have negative 2y plus 3. Okay, little different. Would we ever get x by itself when we're graphing? No. Unless it's a special case. We normally don't ever get x by itself. But when you're doing substitution, that's fine. Now, when I substitute this back in, okay, what equation did I just use? Did I use the top or did I use the bottom? Just, or yeah, we just used the top one. So if I already used the top, I'm going to plug back into the bottom. And now notice what letter you're plugging in for. X. Okay, Jalen, can you tell me what that bottom equation will be after I plug in for x?
3 in parentheses,
Good, 3 parentheses,
negative 2y plus 3
negative 2y plus 3.
Subtracted by y
Equals negative 1. All right. Any questions on what Jalen just did? 3 parentheses, she filled in x, negative 2y plus 3. Take away y, equals negative 1. Okay. This property is called what that I'm about to do? Distribute. I'm going to do 3 times negative 2. That's negative 6 with a y. I'm going to do 3 times 3, and that'll give me 3 times 3? 9, yep. And now I'll just write down the rest of it. Okay, do I have any like terms that I can combine on the left? Yep. Yep, negative 6y, take away a negative y, and that would give me how many? Good, negative 7y plus 9 equals negative 1. Okay. Next step. Yep, we're going to subtract 9. Subtract 9. So I get negative 7y equals negative 10. Again, notice each step, the equation is getting smaller. That's what you want. All right, and what's my last step? Yeah, divide by negative 7. Okay, negative divide by negative. That's a positive. Let's see if that comes out nice. Not really. So let's just leave it as a fraction. Okay, 10 over 7. Okay, if it doesn't come out nice, don't even worry about it. Just 10 over 7. That's the answer. And now, what's always my last step? What do I do with this number? Plug it back in. Okay, and we're going to plug it in. Let's see if I can get both of these on the screen. Just like this. Fill that number back in for y in the equation where the variable was already by itself. So x equals negative 2. Leave a space for what you're going to plug in. Copy down the plus 3. And Corey, what am I plugging in for y? 10 sevenths. Okay. This step, I'm just going to use the calculator because the answer is not going to come out nice. All right. So we've got, and we'll round it off. I'll do negative 2 times 10 sevenths. Okay. I'm just going to do that part first. Make sure you know how to type that in, but on my calculators and Mr. Roy's, you would type it in just like that. You type in exactly that. And what do I have to put on the end? Plus 3. Okay, and whatever we get, I'm just going to round it off. Let's just say 0.14. Okay. How come I didn't round up to 0.15?
Because the number before the 4 is not above 5.
Yeah, the number after the 4 is lower than 5. So don't think you did something wrong if you get a messy answer. That happens. Okay? In fact, if Mr. Roy and I were just to make up substitution problems, like off the top of our head, they probably would not come out to nice answers. Okay? If they come out nice, it's because we had to really think about it to make it nice. Okay? Any questions on that one? All right, so the homework tonight will be a worksheet on 12.2. We're going to give you guys a little time in class to practice some problems. So if you do have any questions, you can ask us.